So let's dive down the rabbit hole by pulling this apart and see what sort of can of worms we open. I've just started the first steps in the rewiring process of the oven, and I'm still not sure how I'm going to go because I may damage the heating element, I may damage the thermistor. I don't know because I don't precisely know where they are, and I'm just going to have to be extremely careful. I've taken the adapter plate off, this plate here, which screws to the other side of this enclosure, and I've disconnected all the wiring, cleaned up all of the eyelets on the connector here so it's ready for resoldering later on, and I've taken all of the small pins off of the lead wires that plug into the A3 board, so I'm ready now to actually start tackling the disassembly of the oven. What I've done, I've got my ohm meter sitting there, and I've got that measuring the continuity of the heater because I'm concerned that with the state of the wiring, that any undue force that I put on this, I'm liable to damage other wiring that I may or may not be able to easily replace. The first thing I did was I ran the scalpel. Well, I could see there was a gap here between the insulation and the outer case, and I ran the scalpel blade around here just to see if it felt like there was a gap, and there is. I've also ran it in here and there was a gap, so what I needed to do was see if I could actually pull the inner oven aluminium oven box section and the insulation out of the case. It looks like it might have been some sort of foam originally as well, and it's gone hard with time. That could be a possibility. Anyway, there's a plate, a cover plate on the oven here inside, and what I've done is I've used one of the screws that holds that plate down. I've screwed it in a little way, and then got a pair of long nose pliers on here, and against getting some purchase against the side of the case, I've actually managed to move the whole assembly out by a good 5 millimeters, and I'm going to see if I can get it out any further, but this looks promising as long as I've just got to be careful, but it should, and it is starting to pull out. In fact, what I'll do now is I'll put the other screw, the right one, put the other screw in here. We've still got continuity on the heater, so that's a bonus. And I'll just tighten that up a bit and see if pulling on these alternately can just get this just to move enough, because once I get it moving and I can get this part out, this is going to be a good first step in the repair of this oven. And we certainly seem to be making some progress here. It'll be certainly easier to push it back in once it's, there we go, pop. Now I can see actually, yes, this looks like this was actually maybe some sort of epoxy or something. It has hardened, and there's some paper material in there. This might be a bit of an issue in replacing these wires. Anyway, what we'll do now is I'll just temporarily disconnect the the heater measurement, and we'll take the wiring out. So at least we've now got the internal section of the oven out. So what I'm probably going to have to do is just fairly carefully cut away at these so I get down to where the wires are, and then we may have to look at using some epoxy. This is actually fairly brittle. Ah yes. Now, here on the schematic they show a thermocouple. But it doesn't actually go anywhere else, and I suspect what they did was, when the oven was being calibrated at the factory, what they did was they had this thermocouple so that they could have something totally, an instrument totally separate to the control circuitry that keeps the oven temperature adjusted. And I suspect that what I've got here, and if there's two wires, I can't actually see this is quite small, but I'm suspecting that this is actually a thermocouple cable. So what I'll do is I'll just put this bit of heat shrink back, or a bit of sleeving back over it for the moment. But if that's already in there, I was looking to actually put my own thermocouple in if there wasn't one, so we can try that. Now what I'm going to do is I'll just reconnect the heater measurement, and we're still 75 degrees C. If I just carefully cut into here, the problem is these wires are basically toast. They are gone, and every single time I repair one and get it ready to reassemble the whole thing, it just falls apart. Next one to it will fall apart. Now here we go. We've got, looks like, if I'm careful, the oven heater is still alright. So if I'm just careful here, I don't know about this one. That looks like there's some harder material there, so I'm going to have to be careful with that one. But it should be possible to just cut away at these wires, or at the insulation material actually, and to expose the wiring, and then I can do something about putting some new wiring in, and then using some sort of, now pulling that apart, that looks like it's actually foam, insulating foam that is actually crystallized. Here, I'll just try and bring that in. You'll see underneath where I've just lifted that ribbon cable, there is at least one wire, two, it's possibly two, one a little bit further back. So the heater element is wrapped around, directly around the aluminium box. Probably a enamel coated wire, probably a nichrome wire or something, and so that's the heating element around there. So it's only just below the surface of where the where this ribbon cable was passing through. So the ribbon cable is very close to it, to the part of the heating element. All right, well that's good, because that gives me a bit more confidence now. Probably not to be much more aggressive than I have been, but gives me the confidence to know where the heating element is. Definitely seeing something here. If I can get that. So you can see it looks like it'd be a circular object in here, and I'm guessing that might be the NTC. So it's obviously over the top of the wire, and it's about an inch, about 25 centimeters, well maybe not even 3/4 of an inch in from the open end of the oven. So that's interesting, and it may be that we don't want to actually remove too much more, because we potentially could just slide the wires through here, and that might be the go. And in fact, what we might do is just slice these wires here, get them off, and we'll just pull that out, because we can actually thread through. Okay, so that's got the first of two out, and I'm thinking that maybe rather than doing too much more damage, we'll actually we'll cut this and pull through, because if we can get the wires through, okay. Right. So just in summary, what I found when opening up part of the insulation on this A58 oven, here we have the thermistor used by the temperature control system to monitor the temperature of the heating element, and that is over the top of the ribbon cable to the right, going through from the oven back up to the connector XA4. And then if we spin this around, the other important point to note is that this wiring here, which is on the left we have the two thermistor wires, and on the right we have the two heater wires. You'll see the two heater wires come through here over the top of the other ribbon cable, which goes through here across, and those wires which we've got here come out to the lower J1 through to J9 connectors on the board. So, and this is why I didn't cut all the way through here, because once we had the ends free, the ribbon was free to move, and it was really easy just to snip
one in and pull through, and then to pass through the new wires through there. Also, this section here is starting to get quite loose and could potentially flake off if I do too much more cutting, and so they're things to watch if you're having to repair one of these ovens. Here's just a quick note to show that I've stripped back the wires on this thermocouple embedded in the insulation for the oven, and we've got a, well, it looks pinkish, but it's, to me, I think it's red and white, and red and white correspond to a J-type thermocouple manufactured in the United States. That was the standard, certainly back in the 80s, and I'm guessing back earlier than that. So I'm going to go with the fact that it's quite possibly a J-type thermocouple, and I can connect that to my Fluke 51 thermometer. I'll have to get a correct plug so that we don't get any extra little potentials due to dissimilar metals, but I'll get the correct plug for that, and we can plug it in and calibrate the oven from my thermometer. Here we go. This is the stuff. It's great stuff, it says. It's a Dow Corning product, polyurethane foam, and it's normally used for lagging around piping. What I'm going to do with it is I'm first going to do a test and actually spray some, and then elevate the temperature on it to 75 degrees C and see if it deteriorates or not. If it fails or goes soft or whatever happens, if it's no good, then we won't be using it on this, and I might have to go back to using some non-acetic acid type silicone, or I don't really want to use epoxy, because if I ever have to try and pull this thing apart again, that'll make it worse.
Okay, this is the first go at re-foaming or putting new polystyrene foam into the sections that I've cut out. What I've done is I've put Kapton tape, wrapped it around the entire block, and then squirted in from the ends with the polystyrene foam. It hasn't gone all the way through down here, but I can just get a big dollop of it and put in there by hand a bit later and let that dry off, and then we'll have to refinish the surface because it has bowed out a little bit from where it was. Not much, but it might present a bit of a problem putting it back into the original housing. So far, the first attempt at this looks reasonably good. After a bit of cleaning up, this has come up reasonably well. Section here didn't fill when applied the urethane previously, but we can just dab on some sprayed out of the can rather than actually spraying it into the area here, because it'll just bow out. But we can then just smooth it off and let that dry. Okay, well, I've just completed the second application of some polyurethane, and I've just used a scalpel blade to scrape the surface fairly flat. So the next step is to get it into the box. Okay, the next part of the reassembly is to get this plate on here, and this plate is has the connector on here for the top of the A4 board, which drives the expander, and get there's 4 screws that fix this plate to the base of the oven enclosure, and then the whole thing plugs in from the top, so that this is upside down. We just have to rewire all the cabling, make sure we've got all of our connections going into the time expander board, the A3 board. These are 3 pages I printed out from my diary that I'm keeping on this project. This table here gives a complete cross-reference, the J numbers for the connectors that go into the boards, into the A3 board, the X4 connector, which is this one here, and with the pin number, the old colours, the new colours, and the actual signal name, which will reference back to the circuit schematic in the service manual. So I've got a complete cross-reference there. I've then placed on the XA4 connector, top connector of the A4 board, the actual J numbers that correspond to those pins, and we've also got there the J numbers on the board, and over here we've got the J numbers, the lower J numbers on the front of the board. I'm not leaving anything to chance with this because I want to make sure it works first go. Some of you may be interested in knowing how I tackle the wiring. I'm only going to give you an example of one because it's quite a boring process. Essentially what I'm going to do is, because we don't have the variety of colours that we did in the other one, I am going to just buzz out. Even these wires are cut off, I can just get on the end and find the relevant colour. And of course I've been doing that without the beeper on, so that was a bit fruitless. I'll try again. Okay, so that one's not one. There we go. Now that's J10. And J10 goes to pin 1 bar. And pin 1 bar on here is this end and top row. So what we shall do now, and I may have to not go as short, I'm going to have to make these wires a bit longer just to get them to fit on the stripper. Okay, here we have a nice thing done. Right. I'll use proper tin lead solder for this, being the consistent with the era. Okay, just clean that off a bit. Now, bring this over to here, put it in the eyelet. Still could do a little bit more solder in that on that eyelet. Okay. And flip off the excess. And we can just double check this again to make sure that we're hooked to the correct one, and seeing we're going into, it should be this one here. Okay, so 17 more to go. Okay, back again. Well, here's the oven assembly all wrapped up. As you can see, we've got all the wiring done in there. Looks reasonably neat now, and we're ready basically to plug this back in. Now, yesterday I received a package. I'll open her up, and inside this package should be here we go, and all the paperwork in there and everything we don't need at the moment. But inside this package we have a plug for a J-type thermocouple, as you can see there. That plug fits into my Fluke 51 meter, like so, and we can connect that up to this thermocouple wire here. So we can then measure from inside, well certainly if not inside the oven specifically, on the surface of the oven, between the outer surface of the oven and the insulation, there's a thermocouple fitted in there, and we can actually monitor the temperature as it would have been monitored when it was originally calibrated in the factory. So that's going to be our next step, is to make sure that we're back with the correct setup of the temperature of the oven. Alright, here's the assembly fixed in position and also plugged into the X4. Just reviewing my image of how all of these wires were connected, and I just realised I've done something very silly. This plate's all got to come off again, because these wires are supposed to fold in underneath this plate and come out this way. So it's always a good thing to have photos of what the equipment was like before you first started pulling it apart. Okay, now we're properly installed. The wires are coming out the back end here and plugging in there. We've got our thermocouple cable ready to go, so it's just a matter of now powering this up and setting up the thermometer and just seeing what we get as an operating temperature. We're sitting at 23.8 degrees at the moment. I shall just plug in the oven, or plug in the mains I should say, and we have power on the oven now, because my extra bit that I've installed, the extra LED, this blue LED here, that indicates that the oven, or both ovens, the time expander oven and the oscillator oven, are now powered. We're getting temperature rise, which is good, so we'll just have to leave this for a while and let it climb to the appropriate operating temperature, and then see where it plateaus out and make the suitable adjustments to set it to 75 degrees C. Well, that's a quarter of an hour, close enough, and we're nearly up to temperature, and I've actually just backed it off a little bit so that the climb is not as dramatic as it was. While testing the oven and making sure it's remaining stable, I thought I'd start doing a few tests on the counter once again. The first thing I did was ran the self-check. It's not working, and I'll just move the camera and you can see what I'm talking about. Okay, here we go. Now if I turn power on, go to self-check, and even if I clear, it's just remaining at 0, and we should be seeing 10 megahertz. One important thing you must do before you ever think that there's an issue, go and check that all the circuit boards are reseated. The processor board A7 here was not plugged in properly, and that was why I was getting a 0 on the display. So just simple things like that can stuff you up. With the plug-in removed from the bay, we have this switch here, which is calibrate, and we switch that over to the calibrate position, and that will show those two counts of N2 and N1 on the display. And these thumb wheels here allow you to adjust the values so that you're within plus or minus 3 counts of 1000 on each of two parts of the display. And these do have some interaction between each other, but it's not too great. As described earlier, to get a more accurate measurement of the period in a measurement, the T1 time and the T2 time, that being the time period between the start pulse and the first clock pulse for T1, and T2 is the time between the stop pulse and the next clock pulse. Those two time periods, T1, T2, are expanded out by 1,000 times in the interpolator, and that allows counting using the same clock to measure off that period, which is, as I said, 1,000 times longer than the actual period. Now, as you can see here, we're in self-check mode, and we're running, it runs at 10 megahertz, and the display is quite stable. If we switch over to the calibrate mode, and I'll just do that now, you can actually see, and in fact you've got to block these off so that you can actually see the particular value. So that is the N1 number of pulses for the T1 period, and this one here is the N2 number of pulses for the T2 period. And you don't worry about the decimal point or the negative sign. These two values have to be set up, when calibrating, have to be set up to within plus or minus 3 counts of 1,000 at the 10 megahertz setting. And as you can see, we're pretty well there. This unit's been running now for about half an hour, and the interpolator is up to temperature. So if we switch back the calibration, and we're back at displaying 10 megahertz with 1, 2, 3, 4, 5, 6, 7, 8 decimal places resolution. In fact, we can go to a 9th decimal place, and you'll see that that just flicks around just slightly. So there's quite a bit of resolution there, and so even if we go on auto here, we've got these 8 decimal places, so we're at 1 kilohertz range here, 1 hertz range here, so we're 0.01 hertz range, so 0.001 if we go here. So yeah, so it's quite good resolution.